Hello. Thanks, everyone. I appreciate everyone for staying so late on this last session. A little bit about myself. I've been working as a professional engineer for ExxonMobil for about 25 years and doing both engineering, project management, domestically and internationally. And as Adam said, we'll be discussing safety, efficiency, reliability, and sustainability, and how the digital twin impacts the real world of operational industry. I really am excited about discussing the advances in this area and having the panel bring their own success stories on this topic. So let me begin. I'll introduce each of the panelists. Our first panelist is Marcelo Gonella Fernandez, is the product owner for Digital Twin and Rich Media at Chevron. Part of the operational technology product line, he leads teams developing the foundational capabilities to enable digital twins at scale. This encompasses enterprise and data management strategy, supporting the use of both manned and unmanned aircraft systems. That will be interesting because I have a little bit of a history with those. Marcelo has worked for 10 years for upstream operations internationally, so that's great experience. He has completed his master's in computer science and executive education in digital business and disruptive technology from MIT and Harvard Business School. Quite an accomplishment. He's been at Chevron for 13 years and is currently based in Houston, Texas. Welcome, Marcelo.
Thank you, Erik.
Our next panelist is Jeff Stroh, Senior Director, Digital and Analytics, McDermott. With his diverse background in engineering and project management, Jeff is responsible for leveraging the latest in digital technology to create new ways of implementing and executing capital projects. He has been leading McDermott's Project Digital Twin Initiative, Gemini XD, for the last 5 years. This was accomplished by utilizing technology and approaches from outside the traditional capital project space to provide delivery certainty. As a leader in his digital analytics team, he focused on the ideation and incubation using best practices both internal and external to the energy industry. Welcome, Jeff.
Thanks, Erik.
Our next panelist, Ben Smith, is the Senior Digital Program Manager for ExxonMobil's Guayana business unit since October of last year. Over his 20-year career at ExxonMobil, he has worked globally in the Americas, Asia, Africa, and Middle East, and lived on assignment in Iraq as an IT manager. His current role merges the knowledge and experience gained during these various assignments in information technology, upstream operations, and digital transformation. Ben recently completed a master's degree in technology management from Georgetown University, where he co-authored a paper evaluating digital twins in the oil and gas industry. Welcome, Ben.
Thanks, Erik. Happy to be here.
Awesome. Our next panelist is Ibrahim Al-Syed, is the Director of Digital Manufacturing at Celanese. He has over 13 years experience in downstream manufacturing assets covering the US, Canada, and Singapore. His passion lies in leveraging digital and data to drive digitization. That's a mouthful. He leads the digital transformation strategy and implementation for the Celanese global manufacturing. His background in digitization strategy was gained working at one of the largest downstream sites for Shell in Singapore. This led to a global digital twin implementation role for Shell. Ibrahim has led several work process initiatives from threat mitigation to reliability-centered maintenance, RCM, to improve asset availability. Welcome, Ibrahim.
Forward to be here.
And our last panelist is Haavard Oestensen, VP of Growth, Digital Twins, Kongsberg Digital. Haavard is an energy industry executive focused on delivering value at the core of the sector through innovative digital solutions such as digital twins. His experience stems from 16 plus years of enterprise software deployments and management consulting, with a key focus on hydrocarbon management and commercial management in the owner-operator space. Haavard currently serves as Vice President of Growth at Kongsberg Digital, with responsibility for its digital energy unit's growth, sales, partnerships, and alliances globally. Welcome, Haavard.
Pleasure to be here, Erik.
Awesome. Well, based on all this combined experience between all the panelists, I think this is definitely going to be a lively and informative session for all of us. So let's go ahead and dive into some questions. Marcelo, tell us about your digital twin journey and some of your experiences related to the connected worker.
Sure. Thanks for the introduction, Erik. This is the third time at the Future Digital Twin event. For me, it's an honor to initiate the discussion for the panel, where we will be talking about the impacts of digital twins in safety, efficiency, reliability, and sustainability. It's not possible to talk about these without saying much about the human component of the digital twins, and that's what I would like to bring to start these discussions, right? So digital twins are not meant to eliminate people. Other than that, it's a tool on our digital transformation journey, looking for a better balance between humans and machines. So there is no business without people. Even when the digital twin is enabling remote operations or autonomous operations, what's really being done at the end of the day is rebalancing roles and responsibilities between people and machines. With this human-centric perspective, we need to look at the worker in the middle of today's digital environment and realize we need to connect the human to the digital environment. We cannot equip them with walkie-talkies and individual standalone monitors and send them to hazardous, dangerous areas and expect everything will be just fine, right? So there's a change, a shift in the mindset. Our workers are becoming connected workers. So they are wearing smart devices that are not only serving to the individual need, but these smart devices are part of an intelligent network to serve the team as a whole. Their vitals can be collected and monitored to make sure they are not dehydrating while working in warm weather, for example. We are able now to detect a fall in real time and many other things that we can do with these connected workers on a complex facility, for example. So these connected workers are using mobile devices to understand and complete their work. Their position now can be tracked across the facility, which can be critical to respond to an emergency, for example. Or we can alert him or he's in an area that he should not be, right? And all this data is being generated and collected in real time and need to be processed and integrated into the digital twin efforts, right, in order to achieve safe and reliable performance. This will drive adoption of better infrastructure in the field, like 5G networks and IoT devices. And companies are realizing now the value and the need of integrating humans into the digital environment and adjusting accordingly. So Chevron, for example, is evolving its digital imperatives that were initially designed to guide us through the digital transformation process to clearly define the behaviors and mindset of our workforce. So we now have what it needs to advance through it. So the new digital imperatives from Chevron are designed with human centricity, so framing the problems around the human experience and how to apply technology to augment human capability and connecting people and assets. So using all these emerging technologies to improve autonomy and help us to free up human time, helping to rebalance minds and machines. So digital twins are a great way to make it happen. So get it back to you, Erik.
Yes, thanks, Marcelo. That was a great insight. People are one of the most important assets we have, and we need to give them the tools and to help them become, make sure they're safe and everyone is working together. Now, Jeff, this is a little bit of my past. I've worked on some large projects, and we didn't have digital twins or anything like that. Can you talk to us from the project standpoint about how a digital twin can leverage things like VR and other technologies and deliver that value that we crave in getting a project done on time and safely?
Thanks. Great question, Eric. Like you said, we're in the EPC space. So we deliver projects, we deliver the assets that the owner-operators ultimately operate for the next 30, 40, 50 years. And all these wonderful things that digital twins can do in the operating space, whether it's improved reliability or safety and sustainability elements, those all start in the EPC phase. And they start with what is defined and what the EPC ultimately delivers at the end of the project. So it's really important to get on the same page with your contractors as these projects are developed, as things are designed, and as they are ultimately delivered. And certain technologies during the project phase can have benefit both during the project and also afterwards. An example is VR. We use reality on pretty much every project today, and that's done from a number of aspects. One is the operations and the maintainability aspect. How can an operator access a valve? Can you maintain a pump? Can you get to different elements? Once that asset is in operation, and we've seen a really good feedback and a really good impact on projects in those safety and reliability areas through engaging the owner operators and the operating and maintenance teams early on. But additionally, we can use that to help the projects deliver more safely in the fabrication and the construction phase. Just like we look at a VR model and determine if you can reach a valve, we can do the same on a constructability assessment to determine whether it's actually safe and is it efficient to produce the plant the way it's designed. Additionally, a lot of the design decisions and the work that goes in ultimately feed that digital asset and that operations digital twin, as we like to call it, once we hand over a project to our customer. So whether it's designing in monitors and sensors to support sustainability aspects, such as energy capture devices to detect increases in power demand, which would drive up greenhouse gases, or enhanced sensoring for leak detection and things like that. We partner with our owner-operator customers to design that into the plants. Emerging areas in the use of robotics help us. We drive those virtually through the plant. If an owner-operator, for instance, would want robotics or drones, all that can be simulated in the design phase to help deliver the end goals that they're looking for during operations. And all these components can be assigned a value and can be assessed early on for very minimal cost in terms of engineering hours and design work. They can yield really big benefits during the operations phase. Back to you, Erik.
Hey, Jeff, thank you. I really appreciate all the efforts in this area. I have lived where you actually have to make changes afterwards because something just didn't quite fit, and it can be quite expensive. So getting that sneak peek and making sure it's safe, that's awesome. My next question is for Ben. Based on your experience and the recent completion of your degree, what are some of those key elements for actually getting the digital twin implemented?
Yeah, so thanks, Erik. I'll try and talk obviously about the key elements to successfully implementing a digital twin, since that's what we're after. And I'd say first and foremost, your team really needs to be laser focused on the use case or use cases that will deliver value through the digital twin implementation. One of the research sources I used in a paper that I wrote in my recent degree called this leading with the business objective. The digital twin needs to align with the business objective and provide a measurable impact on the bottom line. That's the way that source represented that. It's really easy to be seduced to some extent by the technology or the solution itself. There are a lot of really great solutions in the marketplace, and many of them are represented here at this conference. That being said, it's really easy to see the capabilities of what could be, and in the process lose sight of what will really deliver value and make money for your company. Whatever you implement needs to be cost justified. You either need to reduce costs, you need to somehow help increase revenue, and you really need to stay disciplined in implementing those features that will return that value first, and maybe focus a little bit less on the impressive but not as valuable features. If you keep your scope focused on what's most valuable, and most importantly, just get started. Deliver something that's valuable and then continually iterate upon that. Another key success factor in implementing digital twin projects is aligning people, process, and technology. Boston Consulting Group authored an article in 2019 that said that there were two main decision points that led to the failure of digital twin projects. One of those was failing to secure proper commitment from the end users, and the second is underestimating the change in how people work. So there's a reason that when I said we need to align people, process, and technology, that those things are in that order. So if we start with people, many of us are kind of familiar with the age-old question, if a tree falls in a forest and no one's around to hear it, doesn't make a sound. In this particular context, you might say, if you deliver the most impressive digital twin ever and nobody uses it, does it really exist? Your end users really do have to be an integral part of the process. They're going to be the people that are going to use whatever it is you deliver and in turn make money for the company. Moving on to process, a lot of times when we implement a digital twin solution, it creates or alters existing business processes. In ExxonMobil, we're oftentimes looking to use business process modeling to document both our as-is and our to-be business processes. So our users, there's people again, know what's coming and how their work will change when the solution is delivered. And then finally, in the technology space, you need to make sure, obviously, that whatever solution you select is well designed, is robust, and integrates with your existing IT environment, is user-friendly. And that's really it. There you have it, all the things you need to successfully implement a digital twin project. Stay focused and disciplined on what delivers value for your company. Make sure that you align people, process, and technology in that order. Really easy to say, very difficult to do.
Thanks, Ben. Yeah, I really appreciate that. I always call it something like principles are a great thing. You have to get people to buy in on exactly what they want and own it. And if they do own it, it's great. So I love that people, process, and technology aspect. The next question is for Ibrahim. Tell us about using the digital twin for threat mitigation and that reliability-centered maintenance that you'd talked about in your bio.
Yeah, sure. So before I dive into that a little bit, I want to talk about how I see the digital twin in itself, right? So
Oh, awesome! Go for it.
yeah, so the digital twin, to me, when we visualize it from our perspective as Celanese, also is more than just a product or a software that we buy from the market and deploy it, right? To me, the digital twin is the start and end of all in core in supporting the digital transformation journey, right? And I say that because I don't think it's one solution or one software. It's a design, it's a concept with an architecture that supports the virtual representation of your facility and the dynamic behavior of how the facility or the asset acts, right? And it's really about building an integration of all what's happening in your facility in real time, so that you really truly have a twin that's a digital version of your physical asset, right? So if your facility is aging, corroding, leaking, or whatever is happening, the digital twin or the digital replica of that is doing the same in its real time, right? And then the next step of that is not just visualizing what's happening in the digital twin, but also all the workflows that are happening in your physical site needs to be happening in your digital twin. What transactions are happening, what incidents are happening, what tasks are happening. So when we think about digital twin, we think about it bringing the people, the products, the processes, the IT, the OT systems, everything together in the right context, in a view, so that you can make better decisions, but also have automated workflows and better insights in how we move into the future, right? And having said that, when we talk about reliability, it's looking at, hey, can I get to a point where the digital twin is telling me, hey, we have some time series data where, you know, an alarm is about to happen. Here's some work orders that have happened in the past, and there is some kind of anomaly that's happening, and it can give me exceptions or alerts so that I'm in a better position to act, and not only have the insight, but I can actually execute a work order or a notification from the digital twin itself, right? So what we have been targeting and focused on, and from the world where I am in leading this journey, is the ability for us to have that user-centric transformation. And I've heard a few other guys talk about that. Is what we don't want to do is that we're using the digital twin, we're getting all these insights, and then I have to go to like 20 different other systems, 20 other different other processes to actually act on it, right? So how do we create a digital twin environment? Just like how in the physical asset, we walk through the gates, we're going to doing our processes, we're touching the steel, we're executing work. How do we create a digital twin environment where I'm getting the right insights from the right sensors, the right transactions that are happening, from the right historical data that we have, and then for the ability for us to execute work and workflows so that I can act on it in the most automated and seamless way, so that we can optimize and inspire and maximize our people and allow them to use the digital twin with its maximum potential, right? Um, and when we talk about the digital twin playing a role in optimizing our people, our processes, and workflows, it's very important that we create a digital twin environment that's easy to use, has the right visual context. So when we talk about the right visual context, you have the 1D, the 2D, the 3D CAD models, and that twin is actually a physical digital replica of the actual asset in all its dimensions, in all data types, whether it's transactional, that's engineering data, whether it's, you know, time series data, so that you can visualize faster, so that you can have insights faster, you can make decisions faster, and execute your actions faster. So examples like, you know, the ability to visualize, you know, how many safety critical equipment are out of service because you have work orders on it, having that heat map or risk map of your facility highlighted in a 3D model. The ability to get anomaly detections, not just from one type of data like time series, but looking at all the other data types that we have, like SCP work orders or time series, where you might have like levels or pressure indicators swinging, having that alerts and exceptions given to you by the digital twin machine, so that, and then you can take actions from it. The other thing that's also important is the digital twin is playing a key role in helping us work more remotely and autonomously, right? If you have a digital replica that is complete in its all dimensions, from a data perspective, but also from a visual perspective, it allows you to work from your home, from offshore, from low cost countries. You can do planning, you can do scheduling, you can do a lot of things that you don't need to be at the site to do it, and you can minimize the amount of exposure that you have in these high risk or major hazard installations of refineries or chemical plants that we might have. So that's the other thing that the digital twin is enabling in terms of going into the future: the ability to have the right data wherever, whenever you need it, and the ability to execute the work from wherever and whenever you want to execute it, and not necessarily being at the facility to do that work.
Yeah, thank you, Ibrahim. You know, that is great. That's a great concept that you can, digital allows you to be in person remotely. That is just
Yes.
great. You know, I think that's that I come 25 years ago. Yeah, we had paper, running around with papers and writing things. Yeah, it's come a long way, and I'm excited about that. Okay, let's go on to Haavard. Tell us how you accommodate these various use cases and get engineers engaged in using digital twin software. Because we talked about that, discussed it before this conference, and you had some great thoughts. Could you elaborate on that?
Yeah, absolutely. And I think, first of all, excellent points made by the panel here. So I'll really try not to repeat too much of it, but unfortunately, some of it will be a little bit inevitable. But it's good to agree, right? I think that's maybe a good indicator that the industry is moving in a good direction in terms of defining digital twin. So I'll start with just a little definition of how we see a digital twin. And we do see it as a virtual replica of a facility that becomes part of your industrial work surface, complete with contextualized data across function and the asset mix. It is for the owner operator with a complex portfolio that wants to drive digital standardization, unify data and work processes, and to scale quickly so you can have the best decision at every time with your data in hand. So in terms of engagement, and many things have been said about this, and of course the topic of change management is significant. And in our experience, it boils down to three things. One, you have to engage the workers in field, in office, and make work easier and more engaging for them. Otherwise, they'll just go back to their existing tools. Number two, you have to engage management and stakeholders around the asset performance objectives. So that goes to the point that Ben made about the use cases that drive value. And number three, you have to show that this is truly enabling the future of work. So the investment that you're making today, no matter where you are in the organization, will actually position you and the company for a better future. So if we break down that a little bit and we look at making work easier, today we have users like production engineers, maintenance engineers, remote operations staff, etc., supply chain people, with 20 or more systems that they regularly interact with. You're talking about ERPs, inspection systems, real-time data dashboards, hydrocarbon accounting, control system, HMI, reports, the list goes on. And it creates an operational and organizational challenge with a complex landscape and inefficiencies, right? And probably excessive IT spend as well. And as a result, then people are spending a lot of time searching for information, compiling, massaging data, building presentations, custom spreadsheets, and so on, that could be better spent on analytical work and making decisions. So when we come in and present one environment, you're taking away some of that noise and you're making it very tangible and real. People basically don't have to spend that excess time on staging the information for decision making, but they get to be more analytical. The second part was about linking it to the asset performance objectives. And here you can get quite specific, some very specific use cases that are applicable both across upstream and downstream and beyond is reduction of unplanned downtime. So reading reports, you see numbers upwards of 49 million USD reported by upstream operators associated with unplanned downtime events across operators. Similarly, you have the American Institute of Chemical Engineers in 2019 reporting a daily cost of $340,000 a day and an 80,000 barrel producing refinery. So this is a very real problem. So what can we do with the digital twins? We can build better end-to-end visibility, look at value chain impact of shutting wells or taking infrastructure offline, truly looking at it from a reservoir to market view across the value chain with integrated planning and execution. Another point is energy efficiency, where we now see a very clear trend that larger volumes of assets become major consumers. They implement offtake nomination procedures, whether it's localized generation through offshore wind, hydrogen, or they could be grid off-takers. And we have seen results upwards of 1 to 1.5% on grid offtake when implementing energy efficiency through digital twin. Last one I'll mention, although the list is long, so this will be prioritized. Emissions management, which is very high on the agenda again. What we can do with digital twin is we can leverage IoT and virtual sensors to simulate and understand better where the emissions are coming from so we can address the issue at the source. And we can also accelerate reporting of emissions in accordance with regulatory. These are some examples where we can address asset performance requirements specifically. And lastly, enabling the future of work. So this takes on the perspective of the individual, the organization, and the portfolio. And it's about the people. So if you're an individual and you have access to all your information, how does that change your work? Well, you become more efficient with information. If you have 3D models and enriched P&IDs, and you have documents in context, you can get straight to the information. You get better situational awareness on QC, engineering data handover, virtual testing, verification, simulation, what if scenarios, and so on. And Jeff talked about the AR, VR component. We have seen the effects upwards of 70% time reduction, which really matters to individuals. Organization, in terms of the full scope of the asset in the cloud, if you have that, do you need to go there physically? Maybe not. So in short, that can restructure how you address operations, how you organize for it, and enable remote. And lastly, at the portfolio, if you have one integrated environment, centralized support, you can leverage your global organization in a way that was previously unthinkable. End-to-end impact across production value chains, CO2 emissions, and over time becoming semi-autonomous and autonomous. So that's a lot, of course, but it's highly strategic, and it's critical to engage at all levels to drive these initiatives forward.
Okay, yeah, thank you, Haavard. So I get out of this that the big prize is using the data. We have a digital twin, but making use of that data, that's where we're going to have the big money, the big dollar savings, and also the safety that goes along with it. So I have some general questions that they had asked initially. This will be for the whole panel. Pick whoever would like to jump in. Improving maintenance and modeling. How statistical decision making can enhance safety. Does anyone want to take that? Jump right in. Safety is important. Being at ExxonMobil, we do value safety number one. Anyone want to tackle that one?
I'm happy to. Oh, sorry. You can go to Exxon first, but I'm happy to chime in afterwards.
No, go right ahead.
Yeah, I think so. And it goes to consolidating information in one space, right? So if you can stimulate a more stabilized operating regime, you're less likely to trend outside of safety limits. And you can bring in much more control parameters to ensure that you can fall within the safe range. So that speaks to simulating operating performance, which is going to be very critical as the industry moves towards autonomous operations. So obviously you need more parameters to continue providing a safe environment. So that is more on the operational side in terms of the operational performance, but also making available HSE data, safety information for an easy execution of all HSE related processes is something you can do through a digital twin. So if you want to assess, for example, the safety parameters on a given piece of equipment, instead of going into your HSE system and perhaps other adjacent systems, you can navigate straight to the digital twin and get the pre-filtered and contextualized information from there, which makes things easier.
Oh, thanks, Haavard.
And just to add on to what Bart said, a common use case that we see in the safety space is being able to pull in work permitting and active work information into a digital twin so that you can visualize it in the context of the overall plant. So being able to understand what equipment's being worked on, what type of permits are open in each area of the plant, and really benefit to the individuals that are using that in, say, their morning safety meetings or something along those lines. Make sure that everyone's aware of what work is being done where, and the safety impacts that might have if they were just trained in those areas.
Yeah, I think just building onto that, I mean, it's quite powerful in the digital twin. Once you integrate and contextualize your data, how you can visualize the information. And as Ben mentioned, like knowing the locations of where your permits are, where your work orders are, where there might be conflict of work that's happening, or how to optimize your work, right? You might not visually be able to, in the past, tell, okay, this thing and that thing, I can work together and optimize my resources. The more of that we do, the more you minimize exposure to risk and improve safety overall. And that's a benefit. The other thing I also think when we talk about maintenance planning is once you have your data integrated and it's in one environment, the ability to also, and if you have a digital twin that has a 3D context to it, you have to do less and less of field visits and field verifications to go, okay, how much scaffold do I need, what height it should be, what's the design. You can do a lot more of that digitally. And again, you minimize exposure in the facility for less and less people going there.
Excellent. Thanks, Ibrahim. Let's tackle this next one here. Reconfiguration, configuration, and planning. How can asset-related decision-making be supported by the digital twin modeling? I guess
I'll talk to this
around.
one a little bit, Erik.
Awesome. Thanks.
Go ahead.
Go
I
ahead.
was to say, a lot of the things that we do during the construction phase and the fabrication phase naturally translate over to turnarounds and upgrades and brownfield work. Taking that digital twin of what was created in, let's say, the greenfield phase, and being able to look at how it was assembled, how can it be deconstructed. This is all enhanced by a lot of the technology that's available today. Laser scanning and creations of a 3D representation of the as is for you're quite old. That's improved a lot. And in a lot of cases, there's technology available to take that digital twin and blow it apart in terms of creating work packages and deconstruction plans, and then integrating in new clean 3D models and work that can be done all simulated in a digital environment, and all that helps improve the safety. It helps improve the certainty of success of all that work, and ultimately helps drive down the cost of what's being done there.
Now, Jeff, on that one question, with the laser scanning, are we actually turning it into a real model afterwards? Because I remember sometimes if you just digitize something, that's a lot of data that doesn't have a lot of value. You are able to take that laser data and turn it into real PIDs and construction?
Yeah,
3D?
there's a lot of different technologies available on that. I won't mention any vendors specifically here, but taking these old dumb drawings, whether they're even paper form, the intelligence can be added to those and linked to the laser scan or the 3D models that are produced later on. A lot of that is possible now that was not possible even as recently as 5 years ago. So, these existing assets that everybody has can really be given new life if the investment, if the business case is there for the owner operator.
Thanks,
Right,
Jeff.
I can add a little bit at the top of
Yes,
it.
thanks, Marcelo.
The data management aspect of these unstructured data sets are still very challenging for most of the companies. These are large data sets, especially the point clouds. They arrive pretty much without any kind of metadata contextualization, right? So it's a lot of work and effort from the engineering teams to put these data sets into context so they can be consumed in digital twin applications. We have been seeing interesting progress in the 3D segmentation space, right? Interesting research for coming out with the capabilities to automatically detect equipment and pipes and valves directly from the 3D point cloud data sets that will speed up the creation of CAD models out of these point clouds, and even being able to use the point clouds directly in a digital twin solution and linking these detected segmented objects to the SORs. But it's still very challenging, especially in the rendering space as well. Pretty challenging to render very dense point clouds with the web-based tools, for example. So we are still making progress on how to consume and organize these data sets. So I would love to hear experience from the other panelists in this space.
Yeah, definitely. We need to have some sort of software augmentation, because when you're manually trying to link data, metadata together, that's very time consuming. Does anyone have any input on that? On actually getting this metadata connected to all these, older drawings, 3D. 2D drawings.
Yeah, I think
like you
I think
mentioned,
one of
there are.
the. Go ahead.
Go ahead.
Okay, I'll go. So I think one of the things that we've been working on, I think this is the stuff that we're talking about, the drawings, the PNIDs, your data sheets, your 3D models, are a foundation to the digital twin, right? That's your engineering data set that we then need to marry to the operational data set to provide the end-to-end context of the digital twin and its representation from a design perspective and then from an operational perspective. So it's there is a lot of effort going into place. How do we take some of the dumb drawings or PDFs that we might have and create the right relationships and context with what we have, and then this and scrape tags, create hotspots, create relationships with other processes and systems, and then tie that together to a 3D model. Now, one of the things that we've been thinking about is if we're going to build a 3D model by doing a laser scan and then converting it into a CAD model, then you open up a whole bunch of opportunities in going to a complete data-centric engineering environment where you can have your PNIDs, your electrical, your instrumentation data sets all getting connected up, and creating the deliverables that are in the data set that you can leverage in the digital twin. One of the things that I find interesting is because a document will always be a document, and the digital twin can only leverage the document so much, right? So unless everything on a document becomes a data object, for the limitations of the digital twin will always be there, and we just have to find the right balance of how much of you want it to be in data to drive the right value, or how much of the stuff that you want to convert, or how much of the stuff you want it in 3D or photogrammetry or in the right smart format to do the use cases. And it's really around getting that 80% of the value or the 20% of the effort you want to do. So the 80-20, and that's important to drive that balance.
Yeah, Ibrahim,
And I'll just add
you
on
know,
to
I
that by
love.
saying,
Go ahead.
I'll just add on to that by saying in the greenfield space, when you're in project execution, having a very clear data standard that you want to align all of your projects to, whether that's an internal standard or an industry standard like CFAS, can really help further your project in making sure that you're driving data and not necessarily just documents.
Yes, and I've seen that in the past where I love PDF drawings. They're small, but you know what? They're not alive. They don't. You can't move them around. You can't connect them very easily. So, but I still love them because I can carry them in my computer and tons of drawings. But then they're not connected and they're not live. So I can see where that there's going to be some value in making live objects out of all this information. What about partnerships? Go ahead.
Could I just share a little bit around just what, also from a software perspective, kind of what we're thinking, because it's really about this making objects out of the data that otherwise would reside in the documents, right? The document is a way of thinking that, because we've been dealing with documents for as long as time, right? So this is about decomposing that, getting it into a structured database so it can be queryable across these documents. We may still consume it in a human readable format in the view of a document over time, but it's really about creating a data structure that we can extract information from when we need it, right? So from our perspective, we actually have invested a lot into those capabilities, but it starts with scraping information from existing documents and getting addressing the asset structure, the asset hierarchy. And I think there was a question here about 3D models as well. And now working very actively in this space, we see that there's an opportunity for parts of the industry that's creating software to engage with the data acquisition companies to drive better metadata inside the acquisition files, like the files that you get from the acquisition, so that you can actually do something more structured as you build a digital twin based on that. So this is an area that one has to continue investing in from a perspective of driving that data environment, but also to accelerate implementation. So we continue to focus very diligently on OCR scans, rapid contextualization, and being able to deliver that data in a structured manner is really one of our top priorities.
Yes, and one thing, Haavard, I've seen too is you actually need to get this into the contracts with your partner that's building it, because they need to understand that it's part of the contract to give us this data in a format. If you just scan something and send it to me, it's kind of worthless. So we need to make sure that's in the contract, that we get it. The data first is going to be given in a format that we can actually move it into the digital twin.
Yeah, exactly. And we find ourselves in situations now where we receive a file from an owner operator. We look at the opportunities, within that file, and we end up going back to the data acquisition company and seeing if there are things that we can do from the acquisition side. So spot on there for sure.
Excellent. What about partnerships? The future of partnerships. What opportunities do we have going forward? Does anyone want to take a stab at that? Because definitely we want to partner with our everyone we work with, who supplies us, who we everyone. So anyone take a stab at that?
I mean, one comment I'd make to that, Erik, is Ben touched on it as well. These industry partnerships, like CFOS, for instance, really help drive and make these more effective and efficient, in terms of implementing digital twins. If every time a project board you got to do something different, that drives up the cost for everybody. So interoperability between tool sets and standardization of data models and things like that really help ultimately deliver value up and down the project and the asset chain.
Yeah.
Go ahead.
When I think about partnerships, and what clicks to me is that this is an ecosystem that is helping us develop, build, run, and maintain the digital twin. And it's not going to be one vendor or one partner. There's going to be several players in that ecosystem that allows the success of the digital twin. And that really starts with who's having the right data standard across that ecosystem, so that we continue to keep the digital twin standardized, structured, and live. But for example, in the EPC phase, and when you're doing greenfield or even brownfield modifications, you have partners that are aligned on that standard, on the digital twin journey, and they're delivering and developing data in line with that. You have partners that are providing softwares on the engineering side. You have partners that are providing the platform where it's getting ingested. There's partners that are helping you build use cases to execute the workflows that you need to in the digital twin. It all needs to get stitched together against a common data model, against the right standard, into the most seamless experience for our users. And one of the key pieces from a technology perspective is that everybody needs to be able to collaborate and not lock each other into their systems. Otherwise, the digital twin won't work. If we can't integrate, we can't move information seamlessly across the different partners within the same ecosystem.
Excellent.
I'm happy to add to that as well.
Yeah, go ahead, Haavard.
Yeah, and I would just build on what Ibrahim is saying here about ecosystems. I think the industry has changed a bit here, right? Because in the past, and in some sectors, of course, there's a competition for market share, and what it led to was a lot of information silos. We talked about all the systems that people have to do their jobs, and the silos are in part a function of competition for market share. But what we have now seen, and if you look at other industries, and if I'm pointing specifically to Microsoft and Amazon, they've been trailblazing API economies, right? You enable people to build and create interoperable systems on standards like CFOS, for example. And that's now moving into the industrial tech space. And so from our perspective, there has to be a clear strategy, and that is to bring the most relevant data to the end users so they can improve on what they're doing and how they're doing it. And where it is at right now is that it requires partnering up with that in mind. So some of the practical things you can do is you can look at your offering, or you can look at what you want to consume, and you select the collection of partners that interact with each other easily. From our perspective, I will bring up the example of our partnership with C3 AI, where we just piloted seamless integration between enterprise reliability data and models and digital twin, where engineers select parameters for ML modeling in the digital twin and can push that back to an enterprise analytics engine. Together, we were better, right? And we help customer outcomes. Other examples are capabilities across the value chain, where we're partnered with one of the co-sponsors of this event, Future On, to provide end-to-end coverage from concept select through to operations for the benefit of customers, because the market was asking for it. So it's more and more about the integrated experience. It's about leveraging each other's strengths and delivering value through those partnerships. And from a software perspective, it's really about the APIs and the standardized connectivity.
Thanks, Haavard. I'd like to go ahead and, does anyone have any more comments? I'd like to get a few questions from the audience. Is that, if everyone's up for that? Okay, excellent.
Yep.
Leonardo has a question here. We've been talking about several aspects of digital twins, such as right data integration, legacy applications integration, physics-based and data-driven based models, and also visualization. My question is, how companies, panelists, are orchestrating digital twin workflows in an automated way without human intervention? So how are we getting that automated workflow? How do we build it into the digital twin? Does anyone want to try to take that one?
Yeah, I think maybe I'll start with it. I think the way we're looking at it is, once you have built a solid integrated data foundation for the digital twin, the next step for us is, how can I leverage that to do workflows, right? So just simple examples around, getting insights on, failures or anomaly detections that you could be leveraging from a digital twin, and then creating notifications in your CMMS system automatically, which in the past you would do it manually by trending data. So like I used to be a process engineer. You walk into the refinery, you trend tons and tons of time series data, and then you find out anomalies, and then you put in a notification through a paper or a system, and that whole workflow is done manually with a lot of time being spent in analyzing. If the digital twin can do the analysis, give you the exception, also initiate a workflow into the maintenance management process, and also get to a point where it can also plan and schedule and only have people involved and when they need to touch the steel to do something. I mean, those kind of the workflows that we're looking at, how we can enable and also help us do things more remotely.
Thanks, Ibrahim.
Right. I want to.
Yes.
Yeah, I wanted to. Yeah, I think the question is also related to how to automate the process of coming out with the digital twin. So we heard mention to a solid data foundation, which is critical, but unfortunately it's not possible to have a solid data foundation in a completely automated way. Right. So as these digital twins are very much use case specific, there will be always a human interaction, especially on the data enablement layer. Right. So how you harmonize data from different sources to prepare these to be consumed in digital twin applications. It also will require human effort. Right. It's not that easy to reach 100% automation in this space. Especially for companies like Chevron and Exxon, we have hundreds of complex facilities. We are operating in multiple countries. So the problems that the digital twins are trying to solve are fairly different from one from the other, and build this foundation is also very challenging.
Thanks, Marcelo. I have another question. This will be from Allison. Budget is often a major factor when considering the direction to choose in sourcing software. Can you share maybe a model of what kind of ROI or what kind of return on investment is it going to take in order to pull the trigger? Because we know it's not going to be cheap, because it's very complex, right? Getting software. Does anyone have any insights into what direction of what's required of an ROI to pull the trigger on the software? Operator?
I would say it's not just about the software. Actually, it's really around having a credible digital transformation journey with their tied to your business outcomes. So if you're chasing, improvements in reliability, availability, quality of your products, safety, performance, you have to then work backwards on what, processes, what platforms, what technologies you need to enable that, right? And then you either build, buy, or you create a hybrid environment to support that. And what you will find is one of the foundational enablers for those business outcomes is to actually have a digital twin and building that representation, the ability to search information, the ability to find information in the right context, the ability to then build use cases on top of that to create those business outcomes. And also the ability to create work processes around that, right? So I would say you have to look at it holistically, not as just a piece of software that you buy from the market. And the value proposition is significant. I'm not sure if you can get to that value proposition if you didn't start with the business outcome and work it backwards in terms of the right architecture to support that. That's just my thoughts.
Yeah,
Thanks,
I was
Ibrahim.
going to build on that by saying, each individual company has a different funding or valuation model. So there may be a specific investment rate you need to meet, or maybe you need to have a particular NPV in order to justify the investment decision. But all of that tracks back to truly understanding the business problem, understanding what sort of value you think you're going to be able to return by implementing a digital twin, whether that's a reduction in cost, a production uplift because you have better reliability, or you have reduced downtime in your flow lines, whatever the case might be. You've really got to zero into those things, as well as understanding the impact on efficiency that it will have for your workforce. Don't forget to include the productivity gains that you think your workforce is going to get by being able to access a lot of information in a single place. That's what you really have to get started with in order to help understand and really document a very clear business case. Because at the end of the day, your approvers are going to be looking for how much money is this going to make me. The hurdle that each individual company might introduce in order to justify pulling the trigger on a project is going to vary, I think, from company to company.
Thanks, Ben. I have another question here. It's pointed towards Jeff. When we want to deconstruct something, how is the digital twin informing the decommissioning of physical assets?
Well, I mean, it's, maintenance and planning, right? When you want to break down an existing facility, there's a lot of work that goes into that. You have to look at the access to get equipment in there. You have to look at the weight of things. Can I lift this? Can I not lift this? Do I need heavy machinery? There's going to be a team of guys in there, with chain falls and things like that, taking it out. So the better you have a digital twin on the front end of that, the easier all that planning and simulation work is. If you have to go in there and it's a brownfield site and you have to gather all that information on your own, some of it ends up being guesswork, or it ends up adding uncertainty in terms of your execution. So using that digital twin to plan your work and the different steps that you'll take really help improve that activity in the field.
Thanks, Jeff. Let's see here. Wow, Allison has one more question here. We talk a lot about 3D models, laser scans, point cloud, CAD drawings, etc. In relation to engaging the workforce, is photogrammetry the way forward?
Photogrammetry.
Yes, combined or previously mentioned relatability, is that the way forward? Taking photographs?
I mean, my comment on that is that, again,
for,
depends on your use case.
Yes.
right,
Okay,
it depends on the use case, and also the data acquisition cost for each of these data sets are fairly different as well. So you can come out with a 3D model out of a photogrammetry process in much cheaper way than sending someone to to run a laser scan of a complex facility, right? Of course, they will have different uses, so it's completely use case oriented as well. And sometimes it's not unusual to combine multiple models, right? We can combine photo meshes with CAD models and point clouds in the same solution. Sometimes for someone using the digital twin for design work, it makes sense to see a high density point cloud, and for someone doing maintenance and inspection, makes more sense to just see 2D photographs, right? So it's very use case oriented.
Thanks, Marcelo. I guess we're coming up on the time. I'd like to give each one of you a minute just to summarize, quickly what on the digital twin. What's something important that people need to know. We'll start. Ben, how about you? How would you like to start with what's important that the people need to know about the digital twin?
Understand your use case, the value it can return, and get started. Don't study it to death.
Okay, that's always great advice. Ibrahim, what's some words of wisdom?
Yeah, I think it's important that for digital twin to be successful, we put a deliberate effort around getting organized around data. So it's really around transitioning to a data-centric environment, and all the things that are going to get ingested into the digital twin. How do we govern it? How do we maintain it? And otherwise, your digital twin will age and just die a natural death.
Oh, yeah, that would be a shame because it
Yeah.
really is a great technology. Haavard, what's your key tidbits for our audience?
So I think it's a continuous experience, digital twin, and it's all about getting into that continuous state, which means you should focus on rapid deployment. Obviously, use cases are important, but get something up and running. The good news is we can now do these things in 2 to 3 months. It's fully possible. Technology is there, but the mindset needs to be starting small, thinking big, but scaling very fast. So I think I'll leave it at that. But this is not a far-fetched sci-fi novel anymore. It's not the beginning of a hype. It's actual technology that can be realized, and it's very encouraging. So I highly just encourage everyone to take a look at this type of opportunity.
Thanks, Haavard. Jeff, what's your tidbits for our audience?
Well, I think people touched on it a couple times. I mean, at the core of all this is people. The technology is very fancy. Everyone gets excited about, all these pictures and models and simulations, but none of it delivers anything unless you've got people in the mix and you convince the people to buy in and execute.
Excellent. Thanks, Jeff. Marcelo, give us your parting words of wisdom.
Right, I'm with Jeff. Frame the problem around the human experience as well, right? It's not just being purely technology centric or data centric, but at the end of the day, you're building digital twins with people for people, right? So make sure that when you're starting a digital twin project, you design it with human centricity in mind.
Excellent. We still have a few minutes here. I just want to kind of sum up the fact that the people are the biggest important piece of this puzzle, and making people more efficient. That is just a must. We must integrate all these pieces together. We must have actual data that's kind of linked together in some format. Where we can take all this scans and put them all together. Anyone else any more last thoughts?
We're good.
We're good. Okay, excellent. I've got a few more minutes here. We'll see if Adam will chime in a minute here. There we go. Let's take a look and see if he's going to chime in. And I really appreciate the audience. I appreciate all the panelists. Excellent information. I think it's great that we're able to provide some insights to the people out there that this is actually happening. We're going to make it happen. And it was kind of a sci-fi thing a few years ago, but I can see the connected worker, and it's going from to more reality as we get better tools.